Okay, in this unit we're going to be talking more about different ways of integration. We had a unit before the last one. We talked about basic integration, like kind of doing like a reverse power rule and using use substitution to kind of reverse chain rule. Well, we're going to take a couple steps further than that. You're going to learn in this unit how to do integrals of things like trig functions and much more complicated messy things. So the first thing you always want to check when you are talking integrals is you want to check if use substitution is going to work, because that will always be the easiest thing you can do. And I don't think I need to show an example, but you define something as u, and if the derivative of u is also in the integral somewhere, then you can substitute things out, and that's the easiest way of doing it. The next thing I'm going to teach you is called integration by parts, and it is another way of integrating. It's kind of like a more messy use substitution, and this a lot of times will be used when it's kind of like two things of x being multiplied together that are kind of different types of functions. Like for example, if there's like a trig function being multiplied by an e to the x function or something like that, a lot of times integration by parts will work. And so first off, a function that will work by integration by parts is one like this. What if you got the integral of x times e to the 5x dx? How would you integrate that? Well, you might say, look, I'll make 5x u. Well, the derivative of 5x is 5, and there's no, it's just 5 in this equation, so that's not going to work. There's other things you can do. Actually, let me see. Do you think this light will help? Let me see that better. Whatever, I'll leave it on. So, what you're going to do is you do something called integration by parts. So the thing you're going to need to memorize for integration by parts is these 5 letters, L-I-A-T-E. And basically how integration by parts works is you need to define what in here is your u and what is your dv. And that will make sense in a second because it works for the formula. So the things that are over here are u and these are dv. L stands for logarithms, if that's a natural log, or any type of logarithm. I stands for inverse functions, so that would be if you had like inverse trig, or I don't know, things like that. A stands for algebra, or algebraic things. That would just be like if you had 2x or something algebraic. T stands for, wait, I'm spacing out. Well, I know E stands for exponents. Oh, sorry, T stands for trig. I don't know why that spaced out on that. So basically what you have to do is you have a formula. You define something in here as u and something as dv, and then you will use ultraviolet, which I'll teach you in a second. So in this situation, the reason is because you're going to have to take the derivative of u, and you're going to have to take the antiderivative of dv, and we know how to take the derivative of inverse trig functions or log functions, but we don't know how to take the antiderivative of that, and that's the last thing we want to do, because there's no easy way of doing that unless taking the antiderivative of natural log of x is its own integration by parts problem, so you don't want to have to do that. So that's why you'd make that the u. Also, dx, or whatever your d value is, that can also be one of these things. Like, it can be just dx or something. So, in this situation, we have two parts to this. We have the x, and we have the e to the 5x dx, or x dx times e to the 5x. So, x is an algebraic term, so x falls in the middle. So that can kind of go on either side. That will basically just be whichever one isn't used. Now, dv is an exponential one. So you're going to want to make the you're going to want to make the dv e to the 5x dx, because, or else this won't make any sense. Then you're going to want to make the u the x, because x is algebraic, so it can kind of go either way. You know how to take the derivative and the antiderivative just as easily, so in this case, like that. And then we have our formula. Now, if I can find my other colored marker, because I want to emphasize this. This is the integration by parts formula. It's u v minus the integral of v du. like that. And the way to remember that is it's ultraviolet voodoo. Ultraviolet voodoo, and then it's negative because voodoo's bad. That's what we learned. Ultraviolet voodoo. So in this exact problem, it would be x times the antiderivative of this. So you're going to want to also write out what the du is and what the v is. The du, in this case, would be the derivative of x, which is just 1 dx. V right here would be the antiderivative of e to the 5x, which is just 1/5 e to the 5x. So, ultra, which is x, times violet, which is 1/5 e to the 5x, minus the antiderivative of 1/5 to the 5x, or 1/5 e to the 5x, times du, which is just 1 dx, so we'd like that. So then you have to take the antiderivative of what's inside here, and you would get 1/5 x e to the 5x minus, and then the antiderivatives would be 1/25 e to the 5x, and then don't forget the plus c at the end, and that is how to do an integration by parts question. Yes, it's a lot of work, and that's why not a lot of work, but that's why you wanted to use substitution first, to see if use substitution is going to work. You don't have to do any of this. Just remember Lyautey, that helps a lot. So one more thing I want to do in this video is I want to talk about how you can use this to find what the antiderivative of natural log of x is. So, I know it's like shakes a lot when I erase it and write on it. Just deal with it. So I'm going to use blue for this one, because I think my black marker is running out, but you can use Lyautey and integration parts to find out what is this. Well, we don't have a quick and easy way of thinking the antiderivative of natural log of x is blank. We know what the derivative is. The derivative is 1/x, but what is the antiderivative? We don't know easily. So we have to use ultraviolet voodoo. The u in this case, well, because of Lyautey, logs and natural logs is the very first thing. So that means you definitely want to make that your u, because you would be stuck if you had made that your dv, because you don't know how to take the antiderivative of that. That's what you're trying to do, so you'd be kind of stuck. So you have to make the natural log your u, because it's like that. It's the thing all the way on the u side, so you definitely want to do that. And you're going to make your dv. The only thing that's actually left is just dx. So the derivative of ln x is just 1/x dx, like that. And the antiderivative of dx is just x. So ultraviolet, so it would be x ln x minus voodoo, so it would be v du, which is 1/x dx. So obviously the x times the 1/x is just going to make this into a 1. And so when you spell this all out, you get x ln x minus x plus c. You're definitely going to want to memorize this because you'll probably be using this a lot, and you don't want to have to do this every time. But yes, you use integration of parts to find out that the antiderivative of natural log of x is x ln x minus x plus c.